Okay, I'm back, and now we want to talk about Mercury. And the number one thing that determined the fate of Mercury is actually two things. So it's going to be its size, and it's going to be the distance that Mercury was from the Sun. So if we go back to here, and we talk about the factors that influence the terrestrial planets, this time it's going to be both the mass of Mercury and it's going to be the distance that Mercury was from the Sun. So first, let's look at the size of Mercury. It is going to be bigger than the Moon, but not by much. So if you take a look here at the Earth with Mercury right next to it, you notice how small that Mercury is. So Mercury is not even larger than the outer core of the Earth. So it's very small. So that size is going to mean that it cooled off very rapidly, which meant that it lost its ability to have plate tectonics, which means that it lost its ability to sustain an atmosphere, because the volcanism from plate tectonics is going to produce the gases that make up the atmosphere of a planet. And so without the replenishment by those volcanoes, then the atmosphere got thinner. And then also, because Mercury is so small, it doesn't have much gravity, which means it can't hold on to an atmosphere, which means that it lost it. So notice that Mercury is very similar to the Moon. It's a small object, heavily cratered, just like the Moon is, and made of igneous rocks. So you wouldn't expect to find any sedimentary rocks on Mercury. Some interesting things about Mercury. It rotates once every 59 days, and it orbits every 88 days. Do you notice how similar those two numbers are to each other? What does that sound like? Do you remember when we talked about the Moon, we said that the Moon spins once every 30 days and it orbits once every 30 days, and that was because of the gravity of the Earth. So notice that the spin rate of Mercury is almost the same as the rotation rate of Mercury, and that's because of the gravity of the Sun. And so we think that in the future, eventually, given enough time, that Mercury would rotate at the same rate that it would orbit, and it would be locked in just like the Moon will be. Okay, it has a very elliptical orbit, so that for the Earth, for example, the orbit of the Earth looks pretty much like a circle. Now, it's not. It's actually an ellipse. Now, for Mercury, though, it's going to be still pretty circular, but you can tell that it's an ellipse. So it has more of an elliptical orbit, and what do you think is causing that? Well, again, it's pretty close to the Sun. So the gravity of the Sun is altering the orbit of it. And it has another feature, which if you're one of my students, you're not going to be tested on it, but I just think it's pretty cool. And that is that the orbit precesses. So if you take a look at below the gray picture of Mercury, you see that picture that almost looks like an Etch-a-Sketch, where it looks like this, and then it comes back around, and then it does this, and then it does this, and then it does this. So that's precession of the orbital axis. Now, we talked about precession of the spin axis of the Earth, so that the Earth is tipped over at a 23-degree angle, and because of the gravity of the Sun, that currently it's pointing towards Polaris, but in the future it's going to point towards Vega, and then eventually in 26,000 years it would make one precession. So this time it's the orbital axis of Mercury that shifts as time goes on because of precession. And what do you think is causing it? The gravity of the sun. So just kind of an interesting fact about Mercury. Let's talk about its atmosphere. So it has a very, very thin atmosphere composed of hydrogen and helium. Now that is very unusual, because even here on Earth, if you take a party balloon that has hydrogen and you let it go, what happens to it? So that party balloon just goes up into the sky and escapes. So hydrogen and helium escape from the planet Earth because we don't have enough gravity to hold it down. So how is it possible that Mercury would have an atmosphere composed of hydrogen and helium? Well, it's coming from the sun. So do you remember that the sun is constantly blowing materials off of it? So Mercury collects hydrogen and helium that comes off the sun, but basically as soon as it gets there, it escapes. So it's constantly needing to be replenished. But it does have a very, very thin atmosphere composed of hydrogen and helium. So what do you think is the pressure? The surface pressure caused by its atmosphere is going to be very low because it has the very thin atmosphere. What do you think about the temperatures? So let's go back to the moon. So you remember the temperatures varied from negative 130 to positive 120, depending on if you're in the shade or if you're in the sun. So on Mercury, the temperatures go from negative 279 to positive 801 degrees Fahrenheit. So why is it so much hotter on Mercury? Because it's so much closer to the sun. Another interesting thing about Mercury is it has a tail. Just like a comet has material that's being blown off the comet, and that makes the tail of a comet, the material is constantly being blown off of Mercury by the sun, and so Mercury has a tail, just like a comet. So let's talk about the geology of Mercury. Plate tectonics? No. So it's so small, it cooled off so rapidly that it lost its heat, lost its ability to have plate tectonics. Now, one interesting thing, though, is it has a large iron core. The iron core on Mercury is actually even larger than the solid iron core of the Earth. So why would it have this large iron core? Okay, think about how did Mercury form? So Mercury was very close to the sun, and so that means that only materials that could withstand extremely high temperatures would be able to survive. So rocks could, and metals. So metals are able to withstand higher temperatures than even rocks can. So when you reach a certain temperature, rocks liquefy. Metals will liquefy, but you need a higher temperature in order to do that. So it's not surprising that the iron, you would have a majority of the iron would have been closer to the sun than what it would have been out where the Earth is located at, so that Mercury ended up with a larger iron core. It does have a magnetic field, so it's a residual magnetic field, the same way that a bar magnet has a magnetic field. That's the reason why it has it. It does have faults, and so you might think that it has plate tectonics that would cause earthquakes or Mercury quakes on it, but these faults are from shrinkage. So if you've ever made a souffle and you take your cake and you bake it, you take it out of the oven, and then you accidentally slam it on the tabletop, then the cake falls in on itself. And we think that the same thing happened with Mercury, that Mercury was kind of puffed up due to its heat. And then as it cooled off, it contracted and it got wrinkles on it. So those faults on the surface of Mercury are from a result of shrinkage. And then another interesting thing about Mercury is we think it actually has ice in the craters. So on the craters of Mercury, where it's in the shade, there's actually frozen water, frozen H2O. Now you're not going to have the ice any place where there's sunlight, because anywhere that there's sunlight, the temperature goes up to 801 degrees Fahrenheit. Okay, so that it's so hot that you couldn't have any water in the form of ice or a liquid or even a gas on the surface of Mercury unless you're in the shade. The picture that's underneath all of that shows you the topography of Mercury, and so the blue areas are going to be places where there would be an ocean if it had one. So we don't think that Mercury ever had liquid water, but those would be the topographically low areas on Mercury, and then the browns and the greens represent areas where you have mountains on Mercury. Okay, we're going to take a break, and then when we come back, we're going to start talking about where does carbon dioxide come from, and then where does carbon dioxide go.